Hi everyone! In this video, we're going to be factoring quadratic trinomials, specifically when the leading coefficient is greater than 1. Now this is an algebra topic that appears a lot in geometry, so the more practice you get, the more comfortable you'll feel. Now before we get started, I just want to remind you of a little bit of vocabulary. This quadratic expression here is written in standard form. Now the number that's going to be represented by A is called the leading coefficient, B is the middle term, and C is the constant. So in this example here, x squared plus 7x plus 12, the leading coefficient is 1. And you're probably used to doing this using the add multiply method, where we need to find two numbers that multiply to 12 but add to 7. Now this one is probably quick. Our numbers are 3 and 4. And written in factored form, we have x plus 3 and x plus 4. And we're done. However, it's a little bit more complicated when we have a leading coefficient that's greater than 1. In this example, the leading coefficient is 2. And since 2 is not a GCF here, you might have used guess and check to factor it in the past. Now, once you understand the number sense behind guess and check, there's actually a quicker way to factor this. We call it the fraction method. Let's do this first example together. Now, if we take a look, the first term is 2x squared. So we're going to take that and write 2x and 2x as the numerator of a fraction. And we'll keep that to the side here. Now, normally, in your add multiply method, you're looking for two numbers that add to 13, yet multiply to 15. However, because we have this leading coefficient, it's going to be a little bit different. We're still going to have two numbers that have to add to 13. Except now, we need two numbers that don't multiply to 15. We need two numbers that multiply to 2 times 15, so two numbers that multiply to 30. Those two numbers in this situation are 3 and 10, because 3 times 10 is 30, 3 plus 10 is 13. We're going to write those numbers as the denominator of our fraction, so 3 and 10. Now look at our fractions. 2x over 3 cannot be simplified, so we're going to keep that one as is. 2x over 10, however, can be simplified to 1x over 5, or just x over 5 if you prefer to write it that way. Okay. Now our factored form for this is going to have two binomials. Right? Our first binomial, since everything in this situation is positive, is going to be 2x plus 3. And our second binomial, we're going to use the simplified fraction, x plus 5. If you want to check your work, you can distribute, but this is the factored form. All right. So take a look at example 2, pause the video and take a few minutes and try it on your own. Then come back to review your work. Okay, so here's another example of a quadratic trinomial where there's no GCF other than 1, and the leading coefficient is greater than 1. All right, so using our fraction method, we're going to look at this first term and write 3x and 3x as the numerator of two fractions. Right? Normally you would do add, multiply. We're still adding to -2. Except this time we're multiplying not to -8, we're multiplying to -24, because that's 3 times -8. Now because there's some negatives, it might have taken you a little bit longer to find our numbers, but once you did, you should have gotten -6 and 4 as our two numbers. We put those as the denominator of these fractions, and then look at the fractions. 3x over negative 6 does simplify to 1x over negative 2. 3x over 4 does not simplify, so we're keeping that one as is, and we're going to write that as two binomials. Our first one is 1x minus 2. We're using the simplified version, so x minus 2. And our second binomial, 3x plus 4, because that's positive. Right? And that's it. Good job.